This was supposed to be a fun little project, one which would take maybe a couple of weeks and hopefully go a little bit viral. Neither of those things came true. My original vision had been a mechanically operated system, something that anyone could build and operate with the hand or a simple motor. Unfortunately, I just didn't have the knowledge to make it work. I went through more than 10 revisions, starting with what I'd learned working on my Greenhill's own MOC. This used a single stepper to move a shuttle back and forth, changing between 3 motions, rocking side to side and spinning 720 degrees in each direction. The rocking motion would be created by 2 cams, each pushing up on an axle they'd come into alignment with when the shuttle returned to centre. The spinning motion would come from a horizontal turn wheel, which would mesh with turn wheels on the shuttle each time it moved forwards or backwards from centre. Maxwell rocks 4 times and then does 2 full turns, so I needed to first double the input speed for the rotation and then double it again for the rocking, and all this needed to be kept in synchronization, so the cams needed to keep rotating even as the shuttle moved. To achieve this, I used a series of turn wheels under the shuttle's drive shaft, which would remain in contact with the shuttle's turn wheels. Unfortunately, despite a few upgrades to the strength of the build, the heavy weight of Maxwell was too much for the cams to lift, so I had to start over. The Mark II was all about strength, using a stepper for each side of the rocking system and nice big gears to lift a left and a right gear rack. Again, I went for the moving shuttle to change between motions, but due to the gear sizing and spacing I was having to use, I couldn't create a strong shifting mechanism that I was happy with. I'd been reluctant to use a drive shifter ring due to an issue I'd run into with Greenhill's own, but I didn't see another choice for the next design. Maxwell needs to rock 4 times over 8 beats and rotate twice. This is easy to achieve by halving the gear ratio to rock, then halving again to rotate, but throwing a shifter into the mix complicates things. The left side of the shifter needs to be engaged for 8 beats and the right side for another 8. To do this, 2 drive shafts with cams are needed to push a turn wheel, which rotates a catch, which pushes the shifter ring left and right. So each of these drive shafts needs to rotate only once over 16 beats. Still following? Problems arise as the input of the shifter rotates constantly, even when the left and right sides of the gearbox are disengaged. We now have a period of time where the music is still playing, but Maxwell is motionless, so we no longer have a full 8 beats over which Maxwell either rocks 4 times or rotates twice. Now this is where I still remain stuck. I've been unable to calculate the necessary gear ratios to even approximate the movements. As well as rocking and rotating, I now need to account for the distance rotated while disengaged. He still needs to rotate twice, but could rock slightly faster or fewer times. I just need those magical numbers. So if any Lego-minded mathematicians are watching, I'm going to keep trying to crack it, because I'd love it to be a fun, accessible build for anyone, with or without motors. Powered up components obviously aren't cheap, and power functions are becoming scarce. My latest attempt involved the crescent-shaped gear, which would engage with 2 different gears as it rotated, but the back tooth of the crescent remains engaged just beyond each 180 degrees of rotation, turning them that little bit further than I want. I guess I could shave that tooth off.